Hello there. This is Yusuf Odeh, and thank you for joining. If you are interested into air conditioning systems, then I believe this course is perfect for you. Number one, we will look into the introduction to HVAC. Number two would be why and where are HVAC systems used. Number three, we would go into the types of different HVAC systems that are available in the market. Number four is what are the conditions to reach the human thermal comfort. And number five is a conclusive step-by-step example so we can understand more the points we discussed throughout this course.
To start with HVAC systems, let's understand what the word stands for. HVAC. H for heating, V for ventilation, AC for air conditioning. We'll describe more in the next slides. To classify HVAC systems and their applications, we can categorize them into two different, let's say, functions. The first thing is the comfort HVAC systems used usually in homes, offices, restaurants, hospitals. And the other category is the industrial type. Those are used in warehouses, industries, factories. So these are the two major applications. Why are HVAC systems important? There are different conditions we want to provide and control, maintain in a given space. So these are initially temperature, which is how hot or how cold a space is, humidity, which related to the moisture content in that space, purity and quality of the inside air, and the air velocity, the speed inside this area, and the air circulation. All these will be described in the next slides. So what are the major types of HVAC systems available in the market? The first thing is the central system, unitary system, VAV, and VRF. These will be explained thoroughly. The central HVAC system, as you can see over here, different equipment, different devices are available in either a mechanical room or, for example, on the roof. So various components of the system are located in a certain area, and the supply air is directed to the various spaces through a ducting system. So the duct works as a supply medium to the air into the building and the spaces. Unitary unit, from the word itself, it's all the components are enclosed in one area or in a single enclosure from the factory itself, and again it supplies into a duct into different spaces, and each of these systems has some limitations. For example, how much the air flow can reach. All these can be considered in different projects, either high-rise or low-rise, or different types of facilities. VAV HVAC system. In this system, let's take this case where I have two floors. One of them is working and the other one is closed for any reason. So what I have is this VAV unit, a variable air volume. Mainly these are used for applications where there is some flow rate requirement in an area, in a space, and absent in another. So what we can have is we can regulate and make sure the air is supplied into specific spaces. VRF, sometimes called variable refrigerant volume, or VRF, which stands for variable refrigerant flow. So here the refrigerant word we need to consider. As you can see, here's an example. Outdoor unit is connected with the indoor units through refrigerant piping. So the refrigerant itself flows into the different pipes, providing the refrigerant into these indoor units. As an example over here, you can see that some of the spaces are heated, some of the spaces are cooled. So this would give benefit of a more regulated refrigerant flow into the different spaces as per the cooling load required from the occupants. So what is human comfort? Before that, Again, the main objective of an HVAC system is to maintain the environment in an enclosed space at conditions that induce the feeling of comfort to the occupants of that space. So what are the parameters to achieve that human comfort? The temperature, which is number one. The range is usually 22 to 25. Sometimes in winter it reduces a bit due to the different activities of people or the method of wearing the attire itself. So this affects it. The second thing is the humidity, the moisture content. The percentage is 30 to 60%. This is the comfort area. The purity and quality. If you are sitting in the office, there are odors, fumes, dust, or contamination. This would affect the productivity of the occupants. And imagine you are sitting in the office, and what's happening is the air velocity is very high, the noise is very high in a meeting room. You cannot concentrate. Other than that, sometimes what's happening is people are not considering the air circulation, so the percentage of oxygen into that space is minimal, affecting the how much people are getting sick, or for example, the people are getting sleepy in the office, and that's due to negligence or not considering the air circulation into that space. To summarize all these points into an example, imagine you are sitting in this office space, and due to different sources of heat from the lighting, from the windows, from different equipment, photocopier for example, everything's supplying heat into the room. So you are feeling uncomfortable due to increased temperature. So this increased temperature, you suggested some action from the specialist, from the maintenance team. So what they did is they procured or got some AHU, what we call AHU, air handling unit, sometimes called air handler. So as the name mentions, it handles the air in a sort of enclosure. There are different components inside, filters, as you can see, cooling coil, sometimes heating coil, a fan which forces the air into the supply duct into the room. For this case, the air is coming from the mechanical room, which has also different devices, different equipment, so the temperature also is still not being decreased. What they did again is got a portion from the air inside the room into the return ducts, return air, fully recirculating. All the air is recirculated into the air handling units through the coil, supplied again to the room. But again, there is a question mark over here. The coil is not cooling the air. So what's the problem? It's as you can see, it's not connected to any device. And here, what we need to do is connect the cooling coil to a device that would cool the air inside. And this is what we call a chiller. So the chiller works as kind of equipment to decrease the water into chilled water into this cooling coil. So the air, imagine it's what's happening is it's cooling down the temperature. Then with the filters, the fan itself supplies the air into the supply duct and into the room. So you can see over here the temperature decreases. The chiller, as this type requires some kind of heat to be dissipated into the atmosphere, there is another machine or equipment called cooling tower, usually available either externally on the ground level or on the roof to throw out the heat and cool down the chilled water. So as you can see, as a summary over here, what happened is the chiller is cooling the water into the cooling coil. The temperature has decreased. So for now, this is sorted out. But what happened afterwards, after a couple of weeks, everybody realized that the employees are getting sick more often. So there is some kind of issue. What they found out is the CO2 level inside the office is high, and the O2 oxygen level is not sufficient inside the space. So people are getting sleepy, they are getting more sick. So it's difficult to maintain the productivity inside this office space. So what we require again is some interference. So you can see here, let's work from the return air. A portion is thrown outside, recirculated portion over here. And this is the most important point we want to look forward for, which is the fresh air from the external side, which has the oxygen portion, and it's mixed inside what we call a mixing box between the recirculated air and fresh air. Over here there is a mixing box into different types of filters available, because fresh air sometimes has also some kind of dust from the external side, so we need to filter out through the cooling coil, which is again connected to the chiller, into, sometimes we have heaters also, into the supply fan and the room. So the temperature we achieved is 23, the oxygen level is suitable, and everybody is happy. So this is an example of how a full system is working inside an office space. So thank you very much. Hope this clarifies some of the basics of an HVAC system. Thank you. And if you have any more questions, here's my LinkedIn account. Thank you very much for your time, and I'm more than glad to be supporting.